Hello, everybody. I am Gaetan Launay. I am postdoc at the Launay University, and I am in charge of the Renewable Transect. So the purpose of my presentation of today is focused on the research update on the Renewable Transect. So this work is carried out in collaboration with Mattia McRae and Ross Sherlock. So the Renewable Transect is, I just need to put the pointer. Okay. So the Rainy River Transect is located in the Wabigoon subprovince. So the Rainy River Transect is the Dryden Transect, and there the Sturgeon Lake Transect. The Wabigoon subprovince finally share lots of similarities with the Abitibi subprovince. We have a dense network of greenstone belt that surround big and large volcanic intrusions like the Atiqua Air, the Sabas Congratolite, and the Rainy Lake intrusions there. We can also observe lots of regional deformation zones, like the Manitou-Dinowick Deformation Zone, the Wabigoon Deformation Zone, and the Kermon Lake Deformation Zone. And to the south, the Quetico Deformation Zone and the Rainy Lake Deformation Zone. The Rainy Lake Deformation Zone. The big difference with the Abitibi is the absence of gold deposits. So you have the yellow dots, which give you the location of the gold deposit. And we can see that the Wabigoon subprovince is definitively poorly endowed compared to the Abitibi. So if I do a quick zoom on the Rainy River area, we can see that the transect cross-cut two different domains. In the northern part, we have the typical Wabigoon subprovince with the Rainy River Greenstone Belt. And to the south, we have a complex transpressive domain, which marks the boundary between the Wabigoon subprovince to the north and the Quetico subprovince to the south. So this transpressive domain is a wedge of metavolcanic and plutonic rocks, and also thin orogenic sedimentary basin, like the Matter sedimentary domain here, and here the Seine River sedimentary basin. So this area is very complex and record the convergence between the Wabigoon and the Quetico subprovince. So finally, what are our motivation to work on this area? The first motivation is the presence of the Rainy River gold mine, which is the only one active gold mine in the Wabigoon. That means that you have an endowed volcanic center in this greenstone belt. This greenstone belt also numerous thin volcanic gold and silver mineralization. That means that you have a favorable zone for thin volcanic mineralization. However, the geodynamic and the volcanic context for the formation of this kind of deposit is poorly constrained. The second reason is the presence of these complex transpressive domains, which host numerous synorogenic sedimentary basins. So finally, when we compare this domain with the Abitibi, we have more or less the same type of context. That means, lots of deformation zones and synorogenic basin, but these structures are marked by the absence of gold mineralization. So the question is why? Why there are no mineralization in these structures, despite the fact that we have the same type of geological context? What is the difference in terms of geometry of the deformation zone at depth? What is the difference in terms of crustal architecture? And finally, the comparison of this poorly endowed transect with the well-endowed transect of Abitibi will provide some key to understand what are the processes that control the gold mineralization in the regional deformation zone. And finally, this area is very interesting to constrain the convergence, the timing, and the genomic evolution during the convergence between the Quetico and the Wabigoon subprovince. So this is the outline of my presentation. So first, I will discuss about the new mapping, which results from 2 field seasons and the compilation of previous data. Based on this new map, I realized the other part of my work. So I defined different domains, the northern domains which host the stratigraphy, the Rainy River Greenstone Belt. So I discuss more in detail the Rainy River Greenstone Belt in terms of lithophasesis and mineralization. Then I will discuss about the southern domain, which correspond to the transpressive domain, and which hosts the Maver sedimentary basin, which is a synorogenic basin, the timing of the sediment deposition, the provenance of the sediments. And finally, I will discuss about the characteristics of the Quetico deformation zone. And then I will discuss at the crustal scale by applying all of this different information to interpret the geophysical dataset. So the new mapping. So the first task of my work was to update finally the geological map of the Rainy River area. So to do that, I did a compilation of previous geological maps, which are relatively old. I did two field seasons, so one full field season in 2019 and a brief field season in 2020 due to the pandemic situation. I interpret also the airborne magnetic data, so to highlight the different boundary between the geological units and to highlight potential dikes and seal that you can use after to define a stratigraphic marker and correlate the volcanic units at the crustal scale, at the greenstone belt scale. And finally, I will use this airborne magnetic data to define to refine the structures, the regional structures like the Quetico Deformation Zone here and the Pipestone Pinewood Lakes deformations there. So based on the compilation of all of this data, we can propose a refined geological map. So here it's the Sabaskung Batholite, which is a thin volcanic intrusions. Here you have the Rainy River Greenstone Belt with the Rainy River Gold Mine there in the felsic volcanic unit. And in the eastern extension of this felsic unit, you can observe lots of showing and occurrences of gold, silver, and copper. So based on this map, which is a basic tool, we were able to refine the stratigraphy and to define a new volcanic assemblages map to update the structures and the relationship between the different structures in terms of chronology and kinematics. And we realized also some sampling to address geochronology and geochemistry questions. So now I will discuss about the stratigraphy of the Rainy River Greenstone Belt. So here it's a zoom on the eastern part of the Greenstone Belt. So finally, the Greenstone Belt forms a nomokinal sequence between the Sabaskung Batholite to the northwest and the Rainy Lake Batholite to the southeast. And to the south, the Greenstone Belt is bounded by the Quetico Deformation Zone. So we can define 5 different stratigraphic units from the lower to the upper part. So the lower mafic unit is mainly composed of massive and pillowed mafic flows. There are also some very thick plagioclaspheric and amphibolpheric mafic flow that you can use as a stratigraphic marker and that you can use also to correlate with the other greenstone belt at the subprovince scale, like the Betune Lake Greenstone Belt and the Kakagi Lake area. So it's the next part of my work. So then we have the middle mafic units. So this middle mafic unit is separated from the lower by a magnetic break on the airborne magnetic data. The big difference is the presence of lots of gabbro and QFP seals parallel to the stratigraphy. Here you have a detailed map which shows the relationship between the pillowed flows and the seals. In the lower and the middle mafic units, we can find some feeder dikes. Here it's a very great example of a feeder dikes which connect the Sabaskung's thin volcanic intrusions with the felsic volcanic unit. So this feeder dike is usually brecciated. So within the feeder dike, we can find lots of clasts of the different lithophases cross-cut by the dike. So that means we can find some plagioclaspheric flows, some pillowed flows, and some basaltic, some clast of the gabbro and the massive basaltic flows. On the top of the middle mafic unit, we found the Queyron felsic unit, which is mainly composed of massive quartz feldspar porphyry and quartz porphyry. The lower part of this Queyron felsic unit is in shear contact with the mafic middle units, and we interpret that as a fault modified contact. So I think that it was previously a stratigraphic contact, which was then overprint by the deformation. In rare occurrences, you can find some lobate flows and some flow textures in the QFP, and some mafic seals and gabbro intrusions. So that means that you have a bimodal system. And then on the top, of the coherent felsic unit, we have the volcanoclastic unit that you can split in two parts. The Burdett Lake, volcanoclastic unit and the Pinewood Lake. In the both cases, we observe polymictic tuff breccia composed of felsic clast and mafic clast. Here in the Pinewood area, the clasts are very stretched and flattened because we are very close to the Quetico deformation zone. So here you have again an example of clasts strongly stretched. And we have some minor lapilli tuff and laminated tuff layers within the felsic volcanoclastic unit. So finally, the two volcanoclastic units share lots of similarities in terms of lithophases and are strongly similar and belong probably to the same volcanic events. Between the volcanoclastic unit and the felsic coherent unit, you found the mineralization. So the mineralization is mainly hosted by QFP sills and dikes. The mineralization is mainly disseminated on these dikes, like you can observe there. So we have lots of sulfides and base metal sulfides, like chalcopyrite, sphalerite, and some galena. The gold and the copper mineralization, the gold and the silver mineralization is mainly hosted in the pyrite as inclusions within the pyrite. In terms of alteration, the alteration assemblages is very similar to those described in the Renewable gold deposit. So we have sericite and chlorite alteration, overprint by metamorphism, characterized by a garnet and sillimanite and biotite assemblages. In order to constrain the timing of the felsic volcanism, we have collect some samples from the synvolcanic Sabascong batholite and from the quartz feldspar porphyry subvolcanic intrusions. The both samples share the same age of emplacement, around 2720. In the case of the Sabascong, you can observe here you have the distribution of the edges, and you can observe that there are some inherited zircons between 2790 and 2830. That means that you have probably an assimilation of the deep continental crust during the felsic volcanism. Here, it's the edges of the two felsic volcanoclastic units. On the top, it's for the tuff breccia of Burdett Lake, and in the bottom part, it's for the Pinewood Lake area. The two tuff breccia samples have exactly the same intercept edge and the same kind of pattern of distributions of edges. So finally, if we compare these edges with those obtained for the felsic volcanic rock, which hosts the gold mineralization of Renewable, we can see that it's rigorously the same edges. So finally, all of the felsic volcanoclastic units belong to the same volcanic center. And if we consider the age of the emplacement of the subvolcanic intrusions, the coherent phases, we have a minimum lifespan of the felsic volcanism of about 5 million years. That means that you have a short-lived volcanic system, and which can probably explain why we have not a big mineralized system, because the hydrothermal activity was relatively moderate, because the thermal anomaly related to the felsic volcanism could be limited in term of time. So now I will switch to the southern part of the Transect. So here it's a detailed map on this area. So to the north, we found again the Renewable greenstone belt, and here it's the Mather metasedimentary basin. The boundary between the two is the Quetico deformation zone, while to the south, the contact is probably a non-conformity. And in the middle of the sedimentary basin, we found this syntectonic intrusions, which is the Kingsford intrusion. In terms of assemblages, the Mather sedimentary unit is mainly composed of turbidites with some sandstone layers. We can also find some conglomerate thick sequences in the sedimentary succession. And in the southern part, there are some band-around formation, which were strongly deformed and overprint by the metamorphism. So here you have some stretch clast of manitite-rich layers. So finally, we have a porcupine association, maybe associated with some fluvial component with the polymictic conglomerates. In terms of composition, so here you have a typical sample of the polymictic conglomerate, in which you can observe some clast of tonalite, clast of mafic volcanic rocks, and some clasts of the felsic volcanic rocks. In terms of geochemistry, the composition of the sediments form a trending line between the different components, so the mafic volcanic rocks and the TTG and felsic volcanic rocks. That means that the sediments come from local source and are related to an uplift of the Wabigoon and the erosion of the different rocks from composing the Wabigoon during the formation of the sedimentary basin. So in terms of geochronology, so here you have the distribution of the edges in this diagram. You have, finally, the edges are we have a peak at 27 and 25 million years. So finally, that covers the edge of the rocks in the Wabigoon. The youngest population there can allow to define a minimum age of deposition of 2698, while the intrusions, the syntectonic intrusions of Kingsford is characterized by an intercept age of 2686. So finally, the sedimentation is bracketed between 2698 and 2686, which is finally similar to the age of the sedimentation of the Quetico subprovince. We can also remark that there are no old components that definitely confirm that the sediments come from local source, and the formation of the sedimentary basin are related to the uplift of the Wabigoon subprovince. So now I will discuss about the Quetico deformation zone, because this deformation zone accommodates probably the formation of this thin orogenic basin. We can distinguish three deformation events. The first deformation event is related to a tight and isoclinal folding with an east-west direction of the axial planar foliation, like you can see in these stereonet diagrams. This foliation is associated with a strong steep lineation marked by biotite and amphibole. In the vertical section, the foliation is associated with a strong boudinage and vertical stretching. And finally, we can observe some kinematic criteria highlighting a north over south sense of shearing, so a reverse sense of shearing related to a north-south shortening. The second deformation event and the third deformation event are related to a second folding event, as you can see here. So we have the typical Z folds with a northeast southwest S2 foliations. Here you have this is an example of a millenitic corridor which mark the Quetico deformation zones. So the Quetico deformation zone is not just a single big corridor, but it's an association of splays and conjugated shears, like you can see in these rose diagrams. So all of these shear zones are conjugated and are consistent with a northwest-southeast sense of a regional shortening. And finally, we have a transpressive deformation with a dextral sense of shearing. So we can imagine that you have all of these events are connected in the time, and you have a continuity in the deformation. We have first north-south shortening, which switch then with a dextral shearing. So the main characteristic of the Quetico deformation zone is the absence of gold deposits and carbonate alteration. So it's just, like you can see there, it's just a high strength zone with a strong foliation. That's it. No mineralization, no alteration. So the question is why? So to try to provide some explanation, we have to investigate this shear zone at depth. So here it's the seismic profile, which is marked on this map here. So it's a perfect north-south straight line, which is very convenient. So in terms of interpretation, we can divide the crust in three domains: the upper crust, the middle crust, and the lower crust. The upper crust corresponds to the greenstone belt, which is marked by a weak seismic reflectivity. However, we can distinguish some parallel features like there that can finally correspond to the silts of gabbro and QFP that we observe in the stratigraphy of the Renewable River greenstone belt. So these features dip to the south in the northern part, and in the south, they dip to the north. So we have a syncline regional structure. The lower limit of this of this upper domain is there with the dashed line. Below this limit, we have a reflective crust marked by the presence of less reflective domains that we interpret as intrusions. So finally, we can imagine that you have an interior intrusions domain with a TTG gneiss and why not some mafic seals and intrusions. The depth extension of the fault in this domain, so it's limited to the first 15 kilometers, which is very, it's not huge. It's a shallow, yeah, these faults are not deeply rooted in the crust. And then we have the lower part, which is an homogeneous weak seismic, which is an homogeneous crust with a weak seismic reflectivity, with a sub-horizontal reflectors. Now we have the seismic profile with the MT data. So on the MT data, we can distinguish two resistive anomalies and two conductive anomalies. The two resistive anomalies correspond to finally to the greenstone belt and the upper part of the crust. The two resistive anomalies are separated by a moderately conductive zones, which match with the Quetico Deformation Zone, and which is located just below the Renewable gold mine. The two conductive anomalies are the C1. So C1 is related to the Dobby ultramafic intrusion, which is associated with nickel and copper massive sulfide mineralization. So I think that this anomaly is the footprint of this mineralization. And the C2 is just below the Quetico Deformation Zone and can correspond to an altered corridor at depth or an intrusions. So finally, we can propose this synthetic cross-section. And when we compare with the model of crust proposed for the ABTB gold mineralization, finally, there is no difference in terms of organization, in terms of structures. We have the synerogenic basin, which are bounded by the regional deformation zone, but the big difference is the absence of gold mineralization in our case. So why? So if we compare the Renewable Transect with the Ladder Lake Transect, we can observe that in the case of Ladder Lake Transect, the faults, the depth extension of the faults is huge compared to Renewable. For example, the Ladder Lake break, the extension of this fault is about 30 kilometers. While in the Renewable Transect, the maximum depth extension of the fault is about 12 or 15 kilometers. So just above the brutal ductile transition. That means that the fluids produced in the deeper crust during amphibolitization and granulation cannot flow to the surface and form the gold deposit. While in the Ladder Lake area, this fault cross-cut this impermeable barrier, and fluids are able to reach the surface and form world-class deposits. So finally, one hypothesis is to consider that if we are not deep faults in our system, we have no gold. So to summarize, the off-lake and the renewable mineralization belong to the same volcanic center, which is a very short-lived volcanic system of about 4 or 5 million years. The Maver metasedimentary basin, the sedimentation occurred between 2698 and 2686, which is similar to the formation of the Quetico sedimentary subprovince. These sedimentary basins from the erosion of proximal rocks, so probably from the Wabigoon subprovince. We have a porcupine type synerogenic basin. And despite the similarities with the ABTB synergic basin, we have no gold. So the Quetico Deformation Zone is a wide east-west mineralitic corridor. We have not seen any carbonate alteration or gold mineralization. However, we can see a moderate conductive corridor at depth that can be related to a moderate alteration and fluid flow. And finally, the limited depth extension of the Quetico Deformation Zone can be an explanation of the absence of economic gold mineralization in the case of the Quetico Deformation Zone. Thank you of your attention.
All right, great. Thank you very much, Gaetan. Is there any questions? Okay, there is a question in the chat room. Gaetan, do you have any timing constraints on the metamorphism in the garnet limonite bearing units? And did you see any kyanite?
No, I've just seen some sillimanite. The kyanite are overprint by the sillimanite. You mean in the altered rock, right?
I think, Antoine, or this is a question on the chat room. Antoine, maybe you can clarify your question.
Okay.
Yeah, I mean where you've seen sillimanite.
Yeah. So yeah, it's in the altered faceted volcanic rocks.
Okay.
Yeah.
Okay.
So for Rainy River, Patrick Mercier-Langevin and Mireille Pelletier found some kyanite. In my case, it's just sillimanite, but I think it's probably related to the hornfels, the contact metamorphism, because we are very close to granite, to post-tectonic granite intrusions. So maybe during the metamorphism, we switch from kyanite to sillimanite.
Okay, fair enough. Thanks.
Are there any other questions?
Yeah, Gaetan, it's Bruno speaking. From the work you've done, okay, is there something that relates to explaining why Rainy River could be a gold-rich VMS deposit, which is not like as opposed to like your average or normal VMS type deposit?
Yeah, so the Rainy River deposit is in a complex zone actually. So if I come back on the map, okay. So here is the Rainy River deposit, and just to the south of the Rainy River deposit, we have a splay of the Quetico Deformation Zone. So maybe we can imagine that it's a big deposit because we have the conjunction between a thin volcanic system overprint by a late remobilization related to the Quetico Deformation Zones. For example, for the Goliath deposit, we observe exactly the same thing. We have probably a thin volcanic system which was strongly deformed and overprint by the metamorphism and by the deformation related to the Wabikun Deformation Zone. So maybe the conjunction of these two events can lead to the formation of this kind of deposit.
Mm-hmm. Okay, thank you.
Any further questions? All right, guys, thank you very much. Appreciate all the presenters this morning. Thank you very much for some great presentations and sharing your work. And we have a break now till 1 o'clock. Ben has mentioned in the chat room he's going to be hanging out in one of the breakout rooms, and if you want to discuss further. With that, we'll see you guys back at 1 o'clock. Thanks very much.